Good morning. My name is Bryan Vonhagt. Today I'm here to present my foundation presentation and starting with the first topic, the central processing unit. What are the internal components of a CPU? It consists of six major components: control unit, arithmetic logic unit, registers, cache, buses, clock. Now I'm going to explain each of the six major components briefly. Control unit. A control unit is a component of a computer's central processing unit that directs the operation of the processor. It acts as a brain within the CPU, managing and coordinating the execution of instructions by directing the flow of data between the CPU, memory, and input-output devices. Now I'm going to explain about arithmetic logic unit. An arithmetic logic unit is a key component of a computer's central processing unit. It performs arithmetic and logic operations, which are fundamental to executing instructions in a computer system. The key functions of the ALU: number one is arithmetic operations, addition, subtraction, multiplication, and division. Operations on integer or floating point numbers depending on the system. Now I explain how the arithmetic logic works. Inputs: the ALU receives input data from registers or memory and a control signal specifying the operation to perform. Processing: based on the control signal, it performs a desired operation. Output: the result of the operation is sent back to register's memory or other parts of the CPU. The importance of it: the ALU is essential for executing the ALU is essential for executing all calculations and decision-making processes within the CPU. By combining arithmetic and logical functions, the ALU enables the computer to solve complex programs, execute programs, and process data efficiently. Registers. In computing, registers are small fast storage locations within the CPU central processing unit. They temporarily hold data and instructions that the processor needs to access quickly during execution. Examples include data registers, store data for operations; address registers, hold memory addresses for accessing data. Instruction. Instruction registers store the current instruction being executed. Control registers manage processor control and state. Cache. A cache is a small high-speed storage mechanism that temporarily stores frequently accessed or recently used data, making it quickly accessible to a processor or application. It is designed to improve performance by reducing the time it takes to retrieve data from slower storage devices or memory. Now I'm going to explain about types of cache. Processor cache, located inside or near the CPU, stores copies of frequently used instructions and data from main memory. Mm, Level 1. The smallest and fastest, located directly on the CPU. Level 2. Larger but lightly slower, either on the CPU or nearby. Level 3. Shared among multiple CPU cores, larger and slower than level 1 and level 2. Second one is memory cache, used by RAM or disk controllers to speed up data access. Third one, web cache, stores copies of web pages or resources to reduce server load and speed up browsing. Example: browser cache stores images and scripts from websites you visit. Disk cache uses a portion of system RAM or storage to cache frequently accessed disk data. Speeds up file reads and writes. Fifth one, application cache, specific to applications. Example: a database cache that speeds up query results. And now how a cache works. When a program or processor needs data, it first checks the cache. If the data is found, the cache it retrieves it quickly. If not, the system fetches it from the slower memory storage and may store a copy in the cache for future use. Benefits of cache: speed reduces data retrieval time, efficiently decreases workload on main memory and storage. Performance Improves the system responsiveness. Drawbacks. Some drawbacks of this are limited size. Caches are smaller compared to main memory or storage. Complexity. Cache management can add complexity to system design. Stable data. Cache data might become outdated if the source data changes. Now I'm explain about buses. In computing, buses are communication systems that transfer data between different components of a computer, such as the CPU, memory, and peripheral devices. A bus allows multiple parts of a computer to communicate with each other by carrying data addresses and control signals. Types of buses. Number one, data bus transfers actual data between the processor memory and other components. Bidirectional data can flow to and from the CPU. Second one, address bus carries memory addresses from the CPU to other components such as RAM or storage devices. Unidirectional only sends addresses from the CPU. Third one, control bus carries control signals from the CPU to coordinate and manage the operations of the computer. Include signals like read, write, and interrupts. Clocks. Why clocks are important? Synchronization clocks ensure that various components of the system, such as the CPU, memory, and input-output devices, all work in harmony. Timing. They enable the precise timing needed for tasks like data transmission and instruction